morning to one and all. Myself Dr. Rohit Raja, presently working as an Associate Professor and Head in Department of IT, Guru Ghasidas Viswavidyalaya, Central University. Today's topic of my session is insertion sort. It's one of the sorting algorithms, and these are the following topics which we are going to cover in this session. Table of content of the sessions are introduction, characteristics of insertion sort, algorithm, we will give 2-3 examples, code, time complexity and insertion sort applications. See, these are the few standard definitions which we have taken from the different sources. The insertion sort is a simple and intuitive algorithm that efficiently sort a list or array of element. It belongs to family of comparison based sorting algorithm, and it's known for simplicity and ease of implementation. The basic idea behind insertion sort is to divide the input into a sorted and unsorted portion, then iteratively insert element from the unsorted portion into their corrected position within the sorted portion. This is another example which we have taken from the very relevant sources. The insertion sort is a simple sorting algorithm that works similarly to the way you sort playing card in your hand. The array is virtually splitted into sorted and unsorted part. Value from the unsorted part are picked and placed at the corrected position in the sorted part. This is the brief introduction about insertion sort. The insertion sort is a sorting algorithm that places an unsorted element at the suitable place in each iteration. How the insertion sort works, we are going to explain with the help of few examples. Then the description of the algorithm will be very helpful to understand. The insertion sort works similarly as we sort card in our hand in the card game. We assume that the first card is already sorted, then select an unsorted card. If the unsorted card is greater than the card in hand, it is placed at the right, otherwise to the left. In the same way, another unsorted card is taken and put into the right place. A similar approach is used in the insertion sort. Whenever we are taking any example of array of playing card or any list, we used to divide that card into two parts. In the first part, the first element we considered it as a sorted part, and the rightmost array or list is considered to be a unsorted part. Then we used to take the first card from the unsorted part and compared with the first sorted element. If unsorted part is greater than the sorted part, then we do not have to do anything, otherwise we have to swap the values of the card. These things we are going to explain with the help of, we will take the few examples of array, list and the playing cards. The insertion sort is an algorithm used to sort a collection of element in ascending or descending order. This ascending and descending order plays an important role. When we used to calculate the complexity of a insertion sort, then this ascending order and the descending of the array or the list plays very important role. The basic idea behind the algorithm is to divide into two parts. These things already we have discussed in the previous slide, but these are the few standard definitions which we have taken from the renowned sources. A two part like sorted part and unsorted part. Initially the sorted part considered only the first element of the list. Already we have discussed this, but this is important for the students which they were preparing for the competitive exam, while the rest of the list is unsorted part. The algorithm then creates sorts each element in the unsorted part, the picking one at the time and insert it into a correct position in the sorted part. This is the brief description about the insertion sort, how we are performing operations, what are the different steps. To do this, algorithm compares the current element to see when we are implementing algorithm for insertion sort, when we are creating a pseudo code for insertion sort, when we are writing a program for insertion sort, we have to follow a few basic steps. To do this algorithm, the compares the current element with each element in the sorted part. Like suppose after the first pass, after the second pass, after the third pass, the sorted part element will have few elements. In each pass, the element in the sorted list will increase. Like starting from the rightmost element, it may continues to move from the left until it finds an element in the smaller. If sorting in ascending order, or larger if sorting in descending order, then it is a current element. The description, this is a theoretical description of insertion sort. When we are going to explain the algorithm, the basic steps, the pseudo code, it will be very helpful to understand. Once the correct position has been found, the algorithm shifted all the elements to the right of the position to make room for the current elements, and then insert the current element into a correct position. Whatever previous slide we have seen, in all the slides we have explained the almost the common concepts. We have few characteristics of our insertion sort. The algorithm is one of the simplest algorithm with a simple implementation. See, we have seen a number of sorting algorithms previously, but the algorithm, the insertion sort is having a few characteristics due to its simplest algorithm with simple implementation. Whenever we are implementing the insertion sort, it is very easy for the students to implement the code for this. The basic insertion sort is efficient for small data values, and the insertion sort is adaptive in nature, and it is appropriate for the data set which are already partially sorted. See, if the list is partially sorted or fully sorted, it will be very, when we are calculating the complexity, it will help to reduce the complexity of a sorting the algorithm. When we are calculating the complexity of a insertion sort, it will help in that. See, this is the algorithm for insertion sort. This algorithm, or we can also say it as a basic steps of insertion sort. When we are developing a pseudo code, when we are developing a program, these are the basic steps to be followed. And when we draw a flow diagram for the students, when at the students are at the initial level, we used to explain them with the help of flow diagram. Whenever we are writing any program, first we used to draw a flow diagram. The flow diagram is possible when we know the basic steps of insertion sort. The step first, see, the simple step is achieving the insertion sort are listed as follow. The step first, if the element in the first element, assume that it is already sorted. In the first step, we have to assume that we have to consider the first element which is already sorted, and we have to return 1. This return 1 is important when we are writing a functions for the simple C program. And in step 2, pick the next element and sort it separately in a key and store it separately in a key. See, in first step we have assumed that we have considered the first element which is already sorted. In second step, we have to pick the second element or the next element and store it in a separate in a key. Key is nothing but it is a temporary variable where we are storing any element. It will, this key or temporary element will help to compare the value at the time of writing a program. Now, in step 3, now we compare the key with the element in a sorted array. After comparison, in step 4, if the element is sorted array or is smaller than the current element, then move to the next element, else the shift greater element in the array towards the right. Suppose we have taken any array, the first element is already sorted from step 2 to step 3 and step 4. In step 2, step 3, step 4, we have selected the second element and store it in a key. Then the key element is used to compare with the leftmost sorted element, and if the key element is greater than the sorted element, then if key element is greater than, then we don't have to do anything, but the key element is smaller, then the swapping is to be done between the key and the element from the sorted list. And in step 5, once we find the appropriate position for the students, then we insert that sorted element into its perfect place. Then we have to repeat this until the array is sorted. Now, in the whole procedure, suppose we have taken the 6 element in an array, we will see this in the example also. Suppose we have taken 6 element in the array, in the first step the sorted element will be only one element will be there in the first step, and the 5 element will be there in the unsorted list, and every step one value will be find its appropriate place in the sort. The sorted array will have the complete element and the unsorted array will be finished. See, we will take the example. Here we have taken this is the working of insertion sort algorithm. We have considered the example where we have taken an array of size 5. If we want to index it 0, 1, 2, 3, 4, these are the 5 elements. The 5 elements are 12, 11, 13, 5, 6. These are the array where we have to perform the insertion sort, or the sorting algorithm is to be performed in the following example. In the first step, we will consider the element 12, and the 11, 13, 5 and 6 will be in a unsorted array. We will divide the whole array into 2 parts. The first part is a sorted and the second part is a unsorted. In sorted part, the 12, the first element is a 12, and I will consider 12 as a sorted element, and the second unsorted array or the second unsorted list will be consist of 4 element, that is 11, 13, 5 and 6. In the first pass, suppose we are going to initially the first element, like the first element is 12. The 12 we have to consider that the 12 is a sorted element, and 11, 13, 5 and 6 are the unsorted element. Here when we move, then 11 we have to consider as we have to store the 11 into a temporary variable or a key element. Then 11 is compared with the we have 11, 13, 5 and 6. The first element of unsorted list is 11, then 11 is compared with 12, and 11 we have stored that 11 into a key element or temporary element. As the 11 is smaller than the 12, we have compared, if 11 is smaller than the 12, then we have to perform a swapping. Now, the 11 is placed into its appropriate position. Now, we have a array of 11, element will be every time element will be 5 only. Now, we have 2 parts. The first part is a sorted array and the second part is a unsorted. Now, 11 and 12 are the part of sorted array, and 13, 5 and 6 are the part of unsorted array. After the first pass, the 11 reaches to its, or 11 is inserted into its appropriate position. In second pass, we have a two lists, sorted and unsorted. sorted has 2 elements and unsorted has 3 elements. We have to pick one element from a unsorted part, that is 13. 13 is to be kept into a temporary variable. Now 13 is compared with 12. Now 13 is compared with 12. 13 is greater than 12, that is now whatever element which is there in the sorted array, that is 11 and 12, if the 13 is, first we have to compare 13 with the 12. If 13 is greater, then we do not have to compare that 13 with the another element called 11. The automatically we have to consider that if we are comparing first element, that is 13 with 12, if 13 is greater, then we do not have to perform any swapping operation. Automatically 13 is in a right position. Now we have 3 element. After the second pass, we have 3 elements in the sorted. The first is 11, 12, 13 are the part of sorted array, and the 5 and 6 are the part of unsorted array. Now in a third pass, now we have to consider the first element of unsorted list, that is 5. The 5 is to be compared with 13. If 5 is lesser than 13, then the swapping is to be done. Now 5 will reach to, the swapping is done, and the 13 will transfer in the location of 5, and the 5 is transferred, swapping is done. Now the 5 is in a third position. Now 5 is compared with 12, again the 5 is lesser than 12, then again swapping is to be done. Then 5 is compared with 11, then again swapping is done. After third pass, the iteration will be done, and the 5 will reach to the appropriate place, that is the first position. In third position, in third pass, there will be a iteration. At first the 5 is compared with 13, then 5 is compared with 12, then 5 is compared with 11. After this 3 swapping is done, the 5 will reach to its appropriate position, that is first location. Then 5, 11, 12 and 13 are the element of sorted array. Now we have only one element left in the unsorted part, that is 6. In fourth pass, suppose we have taken 5 array, suppose we have taken array of 5 element, the total passes will be n minus 1. After swapping the element of 5 to 12 for the sorted in a, now this is the part of third pass only. In third pass, total 3 swapping will be done. After swapping 5 to 12, then in the next move the 5 is compared with 11. In the last move, when the 5 is compared with 11, this 5, 11, 12, 13 are the output of third pass, and the last element is a part of unsorted array. Now in fourth pass, the last element, that is 6, is to be compared with 13, is to be compared with 12, is to be compared with 11, is to be compared with 5. Here total 4 comparison will be done. In fourth pass, we have to perform iteration of 4 iteration is to be performed, and if the element of unsorted part which we have kept it into a key, if that unsorted element is a part of, if it is smaller than the element of sorted, then swapping is done. Otherwise without swapping we have to move to the next. Now here in step 4 or process 4, the 6 is compared with 13, then swapping is to be done, then 6 is compared with 12, then again swapping is to be done. Then 6 is compared with 11. The element was in last. Now, after first comparison, it moves towards left side. Then again it is compared with 11. Then 6 is smaller than 11. The swapping is to be done. Then in last move, when the 6 is compared with 5, when in the last move 6 is compared with the 5. So, 6, if the 6 is greater than 5, no comparison is to be done, but no swapping will be take place. In comparison, in last pass we have compared the element temporary variable element 6, and the 4 comparison is to be done, and but only the 3 swapping is to be done. After the 4 pass, the array will be sorted and the output of array will be as follow: 5, 6, 11, 12, 13. These are the part of sorted array, and now we do not have any element in the unsorted part. These are the basic steps when we are writing algorithms or when we are writing a pseudocode, how the sorting algorithm is to be performed in the array. The size of array we have taken is 5 here. In the next example, we are going to take, here we have taken the example of the array with 8 elements. The element are of as follow: the 4, 5, 2, 10, 12, 1, 5, 6. These are the elements of array. We have taken array of 8 elements, and in the first pass we will consider that we will divide the whole array into 2 parts. The first part consists of element 4, that is sorted. We will consider the first element as a sorted. The unsorted array will be defined as a 3, 2, 10, 12, 1, 5, 6 are the elements of unsorted part. But in first part we will consider the first element of unsorted part and compared with the first element of sorted array. Now, and the first element of unsorted part, that is 3, we have to store it into a key element. That key element is to be transferred to that key element is 3. 3 is to be stored into a temporary variable or in a key. That element is to be compared with the first element of sorted array. This element is smaller, the key element is smaller than the unsorted element 4. Then comparison is done and we found that the 3 is smaller than element 4. Then the swapping is to be done, and now we have 2 element in sorted array, that is 3, 4. After the first process, then in second pass we will consider, now we have 2 array, one is a sorted, that 2 elements are there, 3 and 4 are the part of sorted array, and from 2 to 6 are the part of unsorted array. Now we will take the first element of unsorted array, that is 2. Now 2 is compared with 4. Now 2 is smaller than 4, then the comparison is done and swapping is to be proceed. Then the 2 will be swapped towards left and the 4 will be swapped towards right. Now 2 we have to compare with 3. Again the 2 is a element smaller than the 3, then swapping is to be done. Like this we have total 8 elements, and 8 elements, the total passes will be, there will be a total 7 passes, and number of element is equal to n minus 1 passes. In every pass, one element will be added in a sorted list and one element will be reduced from the unsorted list. When we complete all the pass, at the last we will get the list of sorted element. This insertion sort algorithm is work very efficiently when the array is already sorted. and when the size of array is less. See, in theoretical description we have seen how we are going to perform the sorting of a playing cards. The card players all knows how to sort. The first card is already, we considered the first card. The first card we have taken A, that we considered it as a already sorted. When we in a playing card, the is considered as a K, Q, J, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. These are the sequence of card. Now, if we want to perform a sorting, we considered the first card it as a as we show that the first card is A, then we considered the first card is already sorted. Then we considered the second card and we compared with the first card. The second card is also in a appropriate place. Then we'll consider like this. We have seen the sixth step in when we have proposed the algorithms, we have to follow the algorithms and this playing card is to be sorted. See, this is another example which we have taken to explain the insertion sort in a brief, and this is the third example which we have considered. Here the size of array is 6, and as we have seen in the first step, the 5 is considered to be a part of sorted list, and the 2, 4, 6, 1, 3 is considered to be a part of a unsorted list. Here at each iteration the array is divided into 2 sub array. The first the first element we have taken, and 2 is compared with 5. In the next slide we will see how the whole sorting take places in the for this particular example. See, here in the first step we have divided into 2 parts. 5 is the leftmost part and 2, 4, 6, 1, 3 is the rightmost part. The 5 is a part of a sorted array, 2, 4, 6, 1, 3 is a part of a unsorted array. In the first part, 5 is considered to be a part of a sorted array. Then the 2, which is the first element of unsorted array, is to be stored in a temporary variable, or it is to be stored in a unsorted part. Then 2 is compared to be with the 5, as 2 is smaller than 5, then we have to perform a swapping. Now 2 will be in an appropriate place, and after the swapping the 5 will reach to its another place. Now in first part the size of sorted array is increased and the size of unsorted array will decrease. In second pass we have to compare the first element, that is 4 of unsorted array, which is compared with the first element of sorted list. The 4 is compared with 5, as the 4 is smaller than the element 5, the swapping is comparison is done and the swapping is to be done. Then the 4 is shifted towards left, then 4 is compared with 2, as the 4 is compared with 2, the 4 is greater than 2. So, no swapping is to be done and the 4 is placed into its will be kept it in a appropriate place. Now after the second pass we have a list of sorted array, that is 2, 4, 5. Now we have 3 elements in a sorted. Like this whole when we perform in this array, in this example of array we have taken 6 elements. So, the total number of passes we have to perform is 5. After the 5th pass we will get the appropriate output, that is 1, 2, 3, 4, 5, 6. See, this is a C program for insertion sort. Here the insertion sort nowadays we are implemented this insertion sort using C, using C++, using Java, using C#, but here we have taken the example because the name of course is data structure with C. So, we are going to implement this insertion sort algorithm with the help of C programming. Here we have this is hash include math.h, we have include math library. Here we have in another line we have include stdio h. These are the two libraries which are important for the C programming, and we have included this C programming. For this insertion sort program, we have created a function to sort an array using insertion sort. Here two functions we have created. One function is for performing a sorting operation, one function is to we have written the function for printing the array, and the main program will be there where we will pass the array and the size of array and call this function. So that the first function is a insertion sort. Here we will receive, in this function we will receive the array and the size of array from the main program. Here we have taken three variables I, k, j. For I and j are the variables through which we are performing the for loop, and key is a temporary variable where we have taken the first element of a array. Here the move elements of array 0 to j minus 1 that are greater than the key of one position ahead of their current position. Here we have two loop, the first is for loop and the second is while loop. Here in while loop we are comparing the value of j is greater than equal to 0 and the array j is greater than key, and here we are comparing the first element with the first element also. Here the array j plus 1 is equal to array j. If the element is greater than the array j element is greater than key element, then we are transferring that element, we are forwarding that element, or we are initializing the element like array j plus 1 is equal to aj. This is to be done when the array j, that the element is greater than the key element, and we are reducing the j is equal to j minus 1, then we are transferring. See, if the array j is greater than key, then we are transferring this value into array j plus 1, and we are reducing the index of j is equal to j minus 1. Then this while loop we have to perform this comparison, and when the while loop is end, then array j plus 1 is to be initialized with the temporary variable, that is key, which at the time of initial, in every phase we are keeping one element, we are transferring or we are storing one element in a key. Here the utility function to print an array of size n. Once the array, this function will be used when the array will be when the insertion sort algorithm is performed, and in the final output is to be print into the console screen. And this is a print array int n is int I for I is equal to 0. The for loop will start from 0 to n, I is less than n and I plus plus. This is if suppose we have 10 element in an array, the loop will move from 0 to 9. That is why the index I or variable I is moving from 0 to I less than n, and the print here in every loop one element will be printed, and the last the whole element will be printed. This is the see two function we have created. One function is a insertion sort, another function is a print array. This two function will be called in the main program of C, which we are going to see in the next slide. See, this is a driver program or a main program, we can say, to test an insertion sort. Here main is here int main, or we can write it as a void main also. So, but here we are returning 0, that is why we have to write int main. Here we have initialized array with 5 element 12, 11, 13, 5, 6. This array and int n is initialized with the size of a array, and two function which we have defined in the previous slide, that is insertion sort array. We have transferred that array, this is the pointer variable, we have transferred this array to that function. We have called the function and we have passed the pointer of a array and the size of a array, and we are going to print array and the size of array and return 0. When we, this is the main program where we have called the two sorting algorithm, two functions. One is a insertion sort function and another is a print. Once it is sorted, then is to be printed into the console screen. See the time complexity of whenever we are writing any algorithms or whenever we are writing any program, the complexity of a program is very important. See we have whenever we are writing any program or whenever we are writing any algorithm, the time complexity is very important. There are three types of complexity. The first is worst case complexity. The worst case complexity of insertion sort is order of n square. Suppose an array is in ascending order and we want to sort it into a descending order, then the worst case complexity will be arise, and the insertion sort, the worst case complexity will be order of n square. See the best case, the complexity is order of n when the array is already sorted and the outer loop runs for a number of times, whereas the inner loop does not run at all. Then the best case complexity will be generated. Then for average case complexity is order of n square. The occurs when elements of an array are jumped order and another ascending or descending order. The space complexity is order of 1 because extra variable key is used. The insertion sort is used when the array is, see the insertion sort algorithm is used when the array is a small number of elements and there are only few elements to be used. This in this case. Okay, thank you very much dear students. All the best for your next lecture. Thank you very much.